we have VCC, VE and VSS to connect. VCC 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 will be directly connected to the plus 5 volts. We also have VSS, that's also connected to, that will be connected to ground. And then we have another pin of this LCD, that is VEE, used for controlling the contrast, that will be connected to a potentiometer. And the potentiometer itself will be connected to one end to plus 5 volts and another to ground. Since we have not connected read write pin to LCD, so we must also connect that to ground. That is it for LCD. Now we have two LEDs. We have connected to P2.5 and P2.6. Let me mention those two LEDs here. As we have discussed in previous lectures, we need to connect a resistor in series with these LEDs. We can calculate the values of these resistors. I will call them R1 and R2. This resistor here I will call R3. Usually R3 is approximately of 10 kilo ohms, 8 kilo ohms, some value of that range. And we can also connect the other end of these LEDs to ground. So they are connected to P2.5 and P2.6. This is 8051 microcontroller, and that leaves us with our connections of our ADC. This is our 16x2 LCD. Moving on to the ADC connections. Okay, that's fine. So there are 8 pins, data pins, that we directly connect to the microcontroller. From D0 to D7 we are connecting these to port 3. That's okay. we have already discussed that. And then there are some other pins. There's a read pin, that's input to the ADC. This is our ADC. Read. And we have another pin as write pin. Write pin. And we also have interrupt pin, that's actually an input to the LCD. INTR. As we have already mentioned, D will be connected to 2.2, WR write to P2.3, and interrupt to P2.4. That leaves us with the circuitry of thermistor only, and some more pins of ADC. Let me try to make the circuit of thermistor here, or let it be here. We have a fixed resistor R4, I will call it, equal to 9 kilo ohms. 9 kilo ohms. And then we have another resistor, that's actually a thermistor. We have connected them in series and across a 5-volt power supply. And this point we have called as VTH. This goes as an input to our ADC, and it is known as ADC's input. V in plus. ADC has another input that's known as V in minus. That will be grounded permanently. Then we have 2 more pins of ADC, in fact 3 more pins. We have chip select, we have 2 grounds, analog ground, and then we have digital ground. All these pins will be grounded. So we have CS, A ground, D ground, and also V in negative. Another pin of this ADC is pin number, that's VCC actually. We have connected that to the plus 5 volts VCC. plus 5 volts, and this is VCC pin. That's okay also. And then we have another pin as V reference by 2, we call it V reference by 2. That's also connected to plus 5 volts, so that gives us a range of 0 to 5 volts. Then we have two more pins, clock R and clock in. Clock R and clock in. As already discussed before, we can connect them like this. A resistor, I will be calling it R5, and it will be equal to 10 kilo ohms. And then we will have a capacitor at the junction of resistor and clock in of approximately 150 picofarads. That will be grounded also. Let me try to get this whole in one frame. So this is our circuit. The only thing missing here is power supply to our microcontroller. We have to give it plus 5 volts to pin number 40 and ground also to pin number 20. Pin number 40 VCC and ground. So let me try to explain the hardware once more. At the output we have two things. We have two LEDs. This one I will call a green LED, that is connected to P2.5, and P2.6 I will call a red LED. So we have two LEDs that will actually indicate the state of this machine, the temperature range it is in. We also have an LCD that we have connected, the data pins we have connected to port 1, and two control pins to P2.1, P2.0. What you are seeing here is the external circuit of LCD that actually powers the LCD and also controls its contrast. So that's okay. The outside is okay. At the input side, what actually we have? At the input side, we actually have a thermistor whose resistance changes with the increase in temperature, and this change in temperature we actually convert using this whole module to the voltage change. So here we are getting the voltage change, but since this voltage change is analog in nature, we have to feed it to ADC before giving it to the microcontroller. So we feed it to the ADC using the pin V in positive, V in ground, V in negative, we ground this pin. And then in the ADC circuit we have three more pins we ground. Chip select, it is always grounded. Analog ground and digital ground, we ground them. We have power source, we have connected VCC to plus 5 volts, and then we have connected V reference also to plus 5 volts, that gives a reference voltage from 0 to 5 volts. We have clock in and clock R, as already mentioned before. I have connected them using this configuration. I have connected a resistor between them, and also a capacitor connects clock in to ground. These values of capacitor and resistor actually determine the clock speed of the conversion of analog signal to the digital signal. Converted digital signal comes over here, and that's fed to the microcontroller using port 3. We also have three control signals for ADC. We have a read signal, that's an input to ADC connected to pin 2.2. We have a write signal, that is also an input to ADC connected to P2.3, and also we have an interrupt end of conversion signal, that's an output from ADC connected to P2.4. P2.4 here, INTR, this is actually here. Okay, so before starting writing the program, let me briefly give an overview of how we will write the program, what we have to do here. First of all, before starting the program, we'll be configuring our ports as input or output port. We have to make port 3 as input, port 1 as output, some pins of port 2, for example P2.1, P2.0, P2.3, P2.4, P2.5, P2.6 as output pins, and one single pin, that is P2.4, as input pins. So that's okay. And then what we have to do, we have to send a read signal, we have to send a, and then we actually have to read the data from ADC. We have to first we have to tell the ADC to start the conversion, then when it finishes the conversion, then we have to read the data from ADC. So to start the conversion, we will actually send a high to low pulse to the right pin here. Using P2.3, we will send a high to low pulse, and after sending a high to low pulse, ADC will start converting. When it finishes the conversion, it will send a low signal. It will send a low signal using the interrupt pin to P2.4. When the microcontroller gets a low signal at P2.4, it will know that the conversion has fixed and I have to pick up the data. That data will be picked by sending a low signal from P2.2 to RD, and the data will be picked at port 3, P3. Then this data will be actually analyzed, and using the formula we have discussed above, this data will be changed to exact temperature, and depending upon in which range this temperature rises, green or red LEDs will be either turned on or off, and also this temperature will be written on the LCD, and also there will be a special message in the second line of the LCD that will actually tell us about the state of the machine, how hot or how cold it is.